In this video, we are going to see the relation between joint and conditional entropy. So, the joint entropy is hxy is equal to summation I equal to 1 to m, summation k equal to 1 to n, pxi, comma yk log 2 of 1 by pxi, comma yk. So, that is summation I equal to 1 to m, k equal to 1 to n, pxi, yk log 2 of this joint probability can be written as conditional probability pyk given xi into pxi. This we have already discussed. That joint probability is conditional probability multiplied by the individual probability, that is pxi. So after that, then summation I equal to 1 to m, k equal to 1 to n, pxi yk. This log of xy, x into y, or log of a into b is log a plus log b. So we have written it as log 2 of 1 by pyk given xi plus log 2 of 1 by pxi. Log multiplication in the log will result in the addition of individual logs, that is log of a plus log of b. So then this pxi yk we have multiplied with both the logs. So pxi yk into log 2 of 1 by yk given xi plus summation I equal to 1 to m, summation k equal to 1 to n, pxi yk log 2 of 1 by pxi. That means this total summation I equal to 1 to m, summation k equal to 1 to n, pxi yk we have multiplied with this one and this one. So two terms we have got. Now this first term is, this is h y given x. This is the entropy h y, conditional entropy h y given x. This formula we have seen in the previous video. Plus now about this so this part. So in here you can observe that there is log 2 of 1 by pxi. So this term has not to do anything with the summation k equal to 1 to n. Now summation k equal to 1 to n has to do with only pxi comma yk. Okay, so let us see what is this summation k equal to n, summation k equal to 1 to n pxi yk, p probability xi comma yk. Now why I am not taking this one? Because there is no k term. Okay, so this is conditional probability. These are conditional probability, sorry, these are joint probabilities. Now we have already seen the property of joint matrix. If this is x1, x2, x3, that means input, and y1, y2, y3, we are taking 3 inputs and 3 outputs. Now you have to this is, and inside there are joint probabilities. For example, x1, y1, this one, all probabilities we are not going to write. Last one is p x3 comma y3. Now summation k equal to 1 to n xi yk. That means k is varying, that means output is varying. That means you are taking y1, y2, y3 and your xi is fixed. That means you are doing the addition like this. And if you do the addition like this, then you will get, here we have seen that here you are getting the input probabilities. If you add row wise, you will get input probabilities. So this is px1. Then if you add like this, you will get px2, and this is px3. And if you add column wise, that means varying the input I, or adding column wise, then you will get the output probabilities. That means this is nothing but p xi. Xi can be 1, 2, 3, anything, because we don't know what is xi. We are here with k only. That means varying the k. So if you are varying k, you will get x1, either x1, x2, x3. That's why pxi. So here we have written so for this we have written here pxi. Now this summation is as it is, because we have removed this part and written it as pxi. Then this summation I equal to 1 to m pxi log 2 of 1 by pxi. Here I terms are there, so summation applies to both these. Now this is what? This is hx. This is hx. So you got hx comma y is equal to hy given x plus hx. Okay. Similarly, there is another formula like this only. And that formula is here hx by y plus hy. So hx comma y, then summation I equal to 1 to m, summation k equal to 1 to n pxi yk log 2 of 1 by pxi yk. Then this px comma yk, xi comma yk joint probability, we can write it as pxi given yk into pyk. This is the formula of joint to conditional. There we have written yk by xi into pxi. Here xi by yk into pyk. Now log a into b is log a plus log b. So this one and this one. Now for this, all this in one group. So that is written, and for this and this is written here. Now this part is h of this, you know, this is nothing but entropy hx by y. This formula discussed in the previous video. So hx given y plus summation I equal to 1 k equal to 1 to n pxi yk log 2 of 1 by yk. Now this summation applies to this only. So summation I equal to 1 to m pxi comma yk. That means you are adding in the joint probability matrix, you are adding column wise because you are varying I. So you are varying here I. Okay, and this is I and this is k. So you are now what? Let us see. Summation I equal to 1 to m. This is for I and k. pxi yk. So you are varying, k is constant. So you are varying I, that means x terms. So 1, 2, 3. You are adding column wise. Yk can be anything, but in this summation we are not concerned with the yk. If you keep the yk constant and varying only x terms, that means you are taking this one plus this one plus this one, and that is nothing but if you add column wise in the joint matrix, you will get the probability of y outputs. So p of yk. This was also discussed in depth in the previous videos. So we have written for this summation k equal to 1 to n and pxi yk, we have written so here for summation I equal to 1 to m p of xi yk, for that we have written p of yk. Then this summation is as it is, summation k equal to 1 to n p yk log 2 of 1 by pyk. So this is nothing but hy. So hx comma y is h of x by y plus hy, or h of y by x plus hx. This is same. This is like x and if you are writing here x by y, here should be y. If you are writing y by x, here should be x. So one thing again I want to just tell you that joint probability is equal to p y given x into px, or px given y into py, and joint entropy is equal to h y by x plus hx and hx by y plus hy. So you can observe here yx, xy, xy, yx. This is, if you remember this one, na, it is more than sufficient. You can then form any formulas. So this is it for this video. So give a thumbs up to this video if you like this content. Also do consider subscribing to the channel for more such videos. Thank you.